right. We are getting back to Advent of Code 2022, problem 5. So we were kind of in the middle of this one, problem 5a, yesterday. I'm not going to go back through the whole problem, but the idea is we're getting an input that looks like this. These are a bunch of crates that are stacked, and there are cranes that need to move them around, and we basically need to move the stacks around based on the instructions, and then read off what's at the top of the crate. So, if we look at our code, though, which is not that, it's this, we are failing some tests, and in particular, we are failing to parse from string, even. So this test is failing. And it's failing because why? Because we're trying to push, we're trying to create a stack that doesn't exist yet, is why. So we need to instantiate stacks to be a vector of is it capacity? I think capacity just sets the capacity. We want let stacks size be row boxes, iter I guess we can just do this lazily. Let's just do it here. Let's just do it here. Okay, so the point is if j is greater than or equal to stacks.length, we want to stacks.push back new, and then we can push the entry onto it. And this can still be back new. All right, and now let's see what happens to our test. Still fails, but it's failing for an actual reason now. So it looks like everything's gotten pushed in onto the same column. Which obviously we don't want. So let's see here. We know we have the right we know our rows look good when we parse them. So this is which row we're looking at from the bottom up. So then we look through the rows. And if there hasn't ever been a column this high yet, or a row this long yet, is the point. Actually, I guess we always know all of the rows are going to be the same length, right? Because we map them into options. But then it looks like somehow everything's getting pushed onto 1. Oh, you know what it is? It's that split white space is splitting on yeah, we don't want to split white space here. We want to split on we want to split on a new line. We split on the new line. We parse the row. We reverse the collection. Double-ended iterator doesn't get interesting. Okay. Alright, let's just collect then. And then we can reverse it here. And now still fails, but we're getting there. Get stack 0. The length should be 2. Should not. Stacks. These are columns. You move 1 from stack 2 to stack 1. Get stack 0 should be 2. Get stack 2 should be 0. Okay. That did that. And now let's look at the rest of the tests. Okay, so can move box is still failing. Can move single box is fine. Can move boxes though. Tried to move a box from a stack with no boxes. Yeah. That's true. Why? But this is the example, is it not? This is the example. But this should be, whoops. This should be 110 at the top. One one zero 302 210 101. Okay, that looks better. Still fails. ZN MCD P, and we were saying that the top boxes are CMZ. That's correct. Okay. Let's run all the tests again. Parses from string is now failing. I thought parses from string was passing. Why is parses from string failing? Index out of bounds. I guess there's a case where you don't realize that you need result row boxes. Hang on, if we know how many rows we have, then the length of any one of these is going to be equal to the number of columns. So let's say assert row boxes dot length greater than 0. We can panic if that's not true. And then we can just say that let n columns be row boxes 0 dot length, because they will all be the same. To collect. Vector of results. Say this here. guess we can say J0, we can allocate the vector. Really, the better way to do this would be to understand, would be to unpack, would be to handle the error within the map. That would be the better way to handle this. Let's see here, Rust handle error within map. Move the result outside. So what if I say that this is a vec of option char? That's not gonna work, but what if I say it's a result string? There we go. Okay, cool. And so then I can just say this. And now it's not even a result. Nice. Okay. Okay, and then we can get rid of this, and this can just be row. Nice. And now this vector can instead be can I say this? Oh, I can't. Okay. And what's going on here? Oh, it doesn't like my question mark anymore. Type annotations needed. Sure. Backup option character. I'll work that now. Okay, let's put the results back. And then here, I guess we can say. Okay. Cool. Test parses from string. Fails. Get stack 0. Certainly should have 2 things in it. So parse row definitely parses into the right thing. Sorry, it looks like it might be dropping frames. that's sorted now. We should be able to get rid of this now. Same story. So this is reversed. So 0 should correspond to the right thing. We instantiate these. We go through the rows. Okay, let's take a look at it in the debugger. So row boxes is okay. Everything has length 6. That seems like too long. Why does it have length 6? It should have length 3. This one has length 3. Seems like something isn't working with parsing of rows. And yet our row test is passing. And we expect the first row to look like ZMP. So where's it getting 6 from? Parse the row string. Where is it getting 6 from? ZMP is the string here. But this all works. It's not this one. We don't want that. It's this one that we're curious about. row boxes. So row boxes is an OK of length 3. For the first one is the right size. The first one is none, sum, none. That's not right. Oh, it is. It's this one. Okay. Then the second one is of length 6 for some reason. It's got like 3 nuns prepended to it before N and C. So N and C are right, but where are the first 3 nuns coming from? Oh, I bet I know. It's this. That's not great. So we're gonna want something like this. And 2 string here. And I actually think and what about now? Still fails. Got an unexpected character. Oh, we need new lines. We need new lines. Still failed. Okay, now what's going on? These new lines seem right. The spaces seem right. Length 4 seems wrong. There should not be a line return at the end, I guess. Is there a line return at the end of the input? There is not. Okay. Whoa. Just gonna go ahead and try to update and cargo clean because we're getting something weird. I'm using nightly, so sometimes it's a little strange. Is it crazy if I try and open another terminal? Oh, you know what's happening. I know what's happening. It's because I'm still in a debugger. Okay. So now I'm rust upping for no reason, but clean. Failed. Still failing. Okay, but now we're getting somewhere. I expect it to be ZN. Yes, because I want the bottom of it to come first. So this is going to be DCM. And oh no, this was correct. MCD. All right, finally. That was a little bit sloppy. And this one passes. That. And okay, so finally just the two problem ones are failing. And if we look at the problem, okay, so we haven't put anything in here. We already tested the example, essentially. Yeah, but we should actually do it. So let's let example be, and let's actually just go, where's my example? So it's this one. What's that, 5 lines? 5 lines yanked. And we will put those here. We will rename this to be example. And we will say assert equal solve problem 5a example. Why is it a vector of a string? Oh, have I just not even, I haven't even done that yet. Okay, that's fine. So solve problem example, and the answer will be, needs to be CMZ. Okay. And then similarly, are we gonna do anything with the shortened input? Let's do that, but let's do it for like 3. And if we look at the input, so move 3 from 8 to 2. This is kind of painful. Let's not bother with that. Okay. And then we're going to do a similar thing up here. So let's just copy all of this. We're not going to know what it actually is yet, but that's fine. Oh, I did a bad thing. There we go. Okay, so all of this. One other thing is this should be solve example 5a, and then this stuff. And we'll make this 5b. these should just be parses string and parses string, which they are. And then this should just be a string. And and we need one other function here on stacks, which is function get top boxes string. And this will just be self.get top boxes dot join nothing. Lens a slice, blah blah blah. Dot string. Hello world. Join the spaces. Join exists. Method join exists for a vector of character, but its trait bounds were not satisfied. Let s equal this. And then return s.toString is what I would like to do. Do I need to collect or anything? Doesn't seem like it. Does this just need to be a character? Oops. It's not a character though. We need to map these into strings. Maybe not the most efficient, but it should get the job done. Okay, and so now these should just amount to what? Stacks instructions are parse input, and then we'll make this mute, and we will say, and this is going to return a string, as will this. And we will say stacks dot move boxes handle instructions. return stacks dot get top boxes string. Okay. And this is a string now, so let's just make it the empty string for a moment. Okay. And this is a vector of strings. This should be parse as string chunk. No. Don't I have a way to get the full string in here? Parse to single string. To single string. And we'll do the same thing here. To single string. Okay. And can't compare string with integer. Sure. Okay. And failed. Parse input. Parse input of chunks is not giving the right number of chunks. Very interesting. Okay. Believe that was just because of the new lines. No. Input. Copy value. And let's see where we're going wrong. Oh, it gives me a dot, dot, dot. Okay, we're definitely only getting new lines, though. Oh, it's because my example is bad. My example also has to have the moves in it. This is slightly painful. So here is the full example. So I guess it's like this. Except that we need what we wanted. Something like I'd do this most effectively. Let's get rid of that. Let's get rid of this. It's gonna mess everything up, but that's okay. Let's put a cursor on each of these lines and go to the end. Something like this. And then we can do the same thing here. And then this very last one just needs a toString. Or maybe the first one needs a toString. Or maybe they all need two strings. Okay. They all need two strings. Let's get rid of that one. And that's what we wanted. And we'll just fix this one at the end here. Okay. And it doesn't like this. They need to have ampersands at the beginning because they are borrowed. Okay. Okay, so we got the double new line in there. And let's try this again. Okay. Feels like I'm missing a line. Still fails. I missed another new line. There we go. Okay. So close. So now the only thing is that somehow we're getting spaces. Which is interesting. Ah. There we go. Okay. And our test is passing. We got a proper answer. Alright. That was a little bit sloppy. I don't love that. Gonna try to be better. I mean, these parsers are always a little bit finicky, but I think I should have done this more as a tokenizer than what I did, which was kind of brute force it a little bit. And I don't think it's the best solution, but it will do. Okay. We got the right answer. Part 2. As you watch the crane operator expertly rearrange the crates, you notice that the process isn't following your prediction. Some mud was covering the writing on the side of the crane, and you quickly wipe it away. The crane isn't a Crate Mover 9000, it's a Crate Mover 9001. The Crate Mover 9001 is notable for many new and exciting features: air conditioning, leather seats, an extra cup holder, and the ability to pick up and move multiple crates at once. Again, considering the example above, the crates begin in the same configuration. Moving a single crate behaves the same way as before. However, the action of moving 3 crates from 1 stack to 3 means that they stay in the same order, resulting in this configuration. Okay. So now we do the same thing, but we have to move them all at once. So this is going to work out nicely for us. This should be very easy because all we need to do is take handle instruction. You know what we'll do? We will we'll take instruction and we will wrap it in, no, the instruction is still good. The instruction is still good. So I guess we'll just update these to be handle instructions. Type. Yeah, we can do it that way. Let's do it that way. Model. Model. And we'll say match model. Model 9000. Then we do this. Otherwise, we do. Oh, it has to be model 9000, and then model 9001. We do another thing that we currently have not implemented. Oh, we did not need to do that. Model, and then here we'll have model. We'll unpack, and then here's where we'll say match model 1000. We will do this. Otherwise, it has to be model 9000. Otherwise, we will do something new, which will be what? I don't know. Let's do unimplemented for the moment. And drive debug. Model 9000 and model 9001. Okay. And we'll just update our tests. of these should pass, although I don't think I actually put in the answer. Ah. I think I didn't put the answer into the last one. Oh, that's fine. We can make model can be what, copy, clone, partial EQ, EQ. That should all be fine. Okay. And let's also go to problem A passes and paste in the answer so that it passes and makes us happy every time it does. Where's my answer? Somewhere I think I can find the old answer. I can. Cool. Okay. Cool. So then we just need to implement this one. So now the number to move we don't want to move each box. We instead want to say self dot move boxes at once from stack to stack. Number to move. And then we will say a function move boxes at once. That means self, number to move from stack to stack. And here we want to pop multiple. So what's the easiest thing to do here? Probably here 0 number to move. We'll say let boxes be this. We will map this. We will say we don't need the thing. Self dot stacks from stack dot pop dot expect. You should always try to move from a stack with no boxes. Collect this. So those are all the boxes, but those are going to have been popped individually. So we're going to get they pop off the end. So they're going to be in the wrong order. So let boxes equal boxes into iter reverse. And then actually, I guess we can just push them, right? So actually, we can probably just say we can probably just say dot for each self.stacks 2stack dot push the box. And then we never need to say this at all. Okay. Because that's for underscore each. Okay. It doesn't like that I'm borrowing it twice. Two closures require unique access to self.stacks at the same time. Pop returns is the actual element, or pop returns? Yeah, pop returns the last element. This also doesn't work. Yeah, we need it to be this. And then let boxes be the same thing but reversed. And then boxes into iter for each. Self.stacks 2stack dot push b. Yeah. Okay. Now everything is looking happy. And only one failure. It's a problem. It's the right problem. And the failure is not implemented. Oh, because I never did this. So this is literally the same thing, except this becomes 9001. And it doesn't like it because of the same thing as before. We need all of this again. And then the new example answer is what? Is MCD. All right, and that passes, and we get a new answer. So let's see if that does it. Boom. Okay. That is problem 5. That took a little longer than I thought. We're starting to get the port built up here, I guess. All right, let's start in on problem 6. It's super dark in here. Hang on a moment. It's a little better. It is extremely gray and rainy where I am. Okay. Day 6, tuning trouble. The preparations are finally complete. You and the elves leave camp on foot and begin to make your way towards the Starfruit Grove. As you move through the dense undergrowth, one of the elves gives you a handheld device. He says that it has many features, but the most important one to set up right now is the communication system. However, because he's heard that you have significant experience dealing with signal-based systems, he convinced the other elves that it would be okay to give you their one malfunctioning device. Surely you'll have no problem fixing it. As if inspired by comedic timing, the device emits a few colorful sparks. To be able to communicate with the elves, the device needs to lock onto their signal. The signal is a series of seemingly random characters that the device receives one at a time. To fix the communication system, you need to add a subroutine to the device that detects a start of packet marker in the data stream. In the protocol being used by the elves, the start of the packet is indicated by a sequence of 4 characters that are all different. The device will send your subroutine a data stream buffer, your puzzle input. Your subroutine needs to identify the first position where the 4 most recently received characters were all different. Specifically, it needs to report the number of characters from the beginning of the buffer to the end of the first such 4-character marker. Okay? For example, here's a thing. After the first 3, there's nothing, blah, blah, blah. First time the marker appears after the 7th character. Yeah, so these are all different. In this case, your subroutine should report 7. Cool. Okay, this seems not hard. Here is our puzzle input. O6. Problem O6. Okay. So there's just one long string, so we may as well just say, what is it, parse 2 single string, input 06, shortened input is not really going to do it, so let's get rid of that. And we'll do the same thing here. 2 single string. And we don't need these. Okay. And then maybe let's let example be LP spaces says math is better than coding. Yeah, I kind of agree with that. But this is what I'm doing today. What's going on? How you doing? How much math do I know? I don't know. I know some math. I studied it in undergrad, and I was an actuary for a while, but I certainly don't know everything. Nobody does. A cute problem for a starter, and it's a positive integer, so that show that 2 mod n, 2 to the 2 mod n, and so on is eventually constant. It's going to have something to do with the order of eventually you're going to get the identity, and then you're going to be just repeating that identity over and over again. More or less. Okay, let's grab this example. I guess there are multiple examples. And the answer is going to be 7 for this one. Solve problem 06A example will be 7. Do I want to put the other ones in too? I guess I will. Oops. This guy. Not what I just took. It sure is. Still what I just took. What's going on here? So let's get rid of all of these first. And then okay, and these are 5, 6, and 10. Okay. And these don't know that they take a string yet, but they will. And those are fine. Okay. So let's just update this guy to take a string. And we're on our way. LP Spaces says, okay, a little intro for myself. You have a PhD in algebraic geometry, low dimensional topology. You work in industry now, though. Oh, very cool. What industry do you work in? Okay, so basically for this one, we're looking for 4 characters, so we just want to have something that can munch the strings, hold on to the last n of them, and compare them, right? So, let's just have something. I guess we should write some tests. Let's write some tests. So let's have something like, what do I want to call it? Muncher, comparer, subroutine. Called it subroutine. So subroutine compares last n, and we'll say something like let mute subroutine be subroutine new subroutine dot consume. I guess we can consume from a string if we want to, but we'll start with a character. Assert subroutine last n were different for should be false. Subroutine. Let's assert that that if you consume were different, 1 should be true, and then subroutine consume B, consume C. So now this for 2 should be true. And for 3 should be true. But for 4 should not be true. And then let's just add on another B. And now now the last 2 are different, but the last 3 aren't different. And the last 4 aren't different. Okay. Cool, and then we'll have a way to consume from strings, and I mean, that's really it. It's not even really worth writing a bunch more tests, I don't think. So, struct subroutine. Oh. And what to say here? Consumed be a vector of characters, and impulse subroutine. Put function new returns a self, just self with consumed as a vec of characters. And what was the other one? Consume. Should take mod self or mute self and a character. Should not return anything. And we just say self.consume or self.consumed.push C. And then last and we're different. Returns a bool, and we can say self.consumed iter. Let's see here, we've been pushing them on to the end, so we want to pop them off of the end. Let's say pop there. What can we do here? 0 through n into iter for each. I don't want to mutate the vector though. What's the nicest way to do this? I guess we can do it like .map I self.consumed consumed length minus I minus 1. Dot collect into a hash set dot count equal, or length equals 1. Means that they're all the same. So equals n means they're all different. But first we have to do a check that if n is greater than or equal to self dot, no, it's greater than self dot length, then we just return false. Otherwise we check whether the length of it, when made unique via collecting into a hash set, is equal to itself. Pub function length itself usize self dot consumed dot length. Okay. I think this should be working. It is indeed working. Okay, so then we just need to be able to consume from a string also. So let's say, what to say here? Pub function consume maybe it's just maybe let's actually do it as pub function identify first time n are different, not self n usize let's not even do that. Let's just, because I don't know what the puzzle output is, let's just say let mute subroutine be subroutine new input dot chars dot into iter c subroutine I guess I have to do this in a loop. So for c in input.chars subroutine dot consume c actually let's make this ic and we can say enumerate here. So we consume, and then we say If subroutine dot last n were different, where n is 4, we want to return I plus 1, right? Otherwise, we want to panic to the end of the string without finding a distinct group. Okay. And I just want to make sure that I'm indexing this correctly. So, character 5. So these are unique, and that is the 5th character, which would be index 4. So we have to add 1. That seems right. Cool. Let's run this. Okay, everything passed, and we got all the way to 1647, which we suspect is the answer. Let's take a look. 1647 is the answer. Part 2. The device's communication system is correctly detecting packets, but still isn't working. It looks like it also needs to look for messages. A start of message marker is just like a start of packet marker, except it consists of 14 distinct characters rather than 1. Here are the first positions of the start of message, blah, blah, blah. How many need to be processed before the start of message marker is detected? All right. Let's do that. So let's yank all of these. Let's put them here. And all of these are going to need to be problem B, and the answer is 19. The answer is 19. The answer is 23. The answer is 23 again. The answer is 29. And I didn't do the last one. Let's do the last one. And this one is 26. Okay. And now this should be very easy. It is the same thing. So, I mean, if I were trying to be good, I would put this in a function and just call it on 2 different numbers. I'm not going to be good because this is really simple. 14 was it? Uh, 14 distinct characters rather than 4. And oops, problem 6. This was the answer for the last one. 1647. And 2447. And let's see how we did. 2447. Boom. All right. Day 6, not so hard. Cool. I have another, like, 20-ish minutes. Should we start on number 7? Or should we do something interesting? Let's start. Okay, day 7, no space left on device. You hear birds chirping and raindrops hitting the leaves as the expedition proceeds. Occasionally, you can even hear much louder sounds in the distance. How big do the animals get out here anyway? The device the elves gave you has no problems with more than just its communication system. You try to run a system update. No space left on device. It's got a flag here that's pretty pleased with sugar on top. That's funny. Perhaps you can delete some of the files to make space for the update. You browse around the file system to assess the situation and save the resulting terminal output. The file system contains a tree of files, plain data. Ooh, this is going to be the first real fun one. Plain data and directories, which can contain other directories or files. The outermost directory is called /. You can navigate around the file system, moving into or out of directories and listing contents of the directory you're currently in. Within the terminal output, lines that begin with $sign are commands that you executed, very much like some modern computers. CD is change of directory. CD ... Okay, this is all Unix stuff. Given the commands and output above, you can determine that it looks like this. Here there are 4 directories. Since the disk is full, you need to find the directories that are good candidates for deletion. To do this, you need to determine the total size of each directory. The total size of a directory is the sum of the sizes of files it contains, directly or indirectly. Directories don't have an intrinsic size. Total size of directory E is blah, blah, blah. To begin, find all directories with a total size of at most 100,000. Find the sum of at most 100,000. Okay. Then calculate the sum of their total sizes. This process can count files more than once. Okay, so the point is that we have CD'd into essentially everything. But then we're double counting some files. Oh, I see. Okay, so we go through the commands, we work out the file tree as much as we know it, and then we go through each directory, and if it has 100,000 or less size, we add it up. And even though E is within it contains E, which contains, yeah, okay, so even though like I is within 2 of the files that count, we still double count it here. Okay, I get it. Okay, let's take a look at the puzzle input. 7. Okay. So, I mean, it's kind of implied that we're doing this in a somewhat smart way, but it's not actually obvious that we are. So we go to the root, we list all the directories, we cd into one of them, we list it, and so on and so forth. But we have no guarantee that we actually go through every directory, right? Yeah, we don't really know. Okay, so we're going to get to do some stuff with trees. Should be fun. Yeah, this is going to be the first actually interesting one, I think. Alright, so we should set up our test cases. I'm going to go ahead and put this in a different file, actually. Example input 07. Because I am going to want to use that. And then I don't think I ever really want to do my own input. So we'll just say let example be input parser new parse as string, and this will be example input.txt 7.txt. And then we can say let answer be solve problem 001A example, and assert that the answer is whatever it is. 95437. 95437. Okay, so then we're going to need to do some things with trees. So let's test file tree. Constructs, we'll say. And we'll have something like tree is file tree new. Should be mute. Tree children vector of strings probably. You know what? Actually, this should be file tree node. File tree node. Children. Maybe we just call this empty. Children will be a vector of here we can just say child 1, child 2, child 3. And maybe we'll do we'll implement from for strings. So that should work fine. And then let's say tree.size should be 4. Tree.depth should be 2. And tree dot the sizes are only at the leaves. Interesting. So at the leaves, they have sizes in addition to having names. So tree node empty isn't really a thing, actually. So, and this is one of the benefits of doing tests, is that you get to sort this stuff out ahead of time. So what if instead we say file tree node not leaf. What's the opposite of a leaf? Branch. A branch. A branch, all a branch knows about is it's got a name and it has its children. So it should have contents. File tree node directory. So maybe we say directory children, and then this becomes let children be 0 through 3 into iter map file tree node file child, say format child I, and then it also needs a size, so we'll just say I. We need to collect, and is it going to know what that is? Yes, it is. node doesn't exist yet, but that's fine. That's going to be a string. That's fine. And then it'll be a directory of children. Some sizes will be 6. 1 plus 2 plus 3. And some sizes if will be take a node and we'll say node dot size is less than or equal to 100,000. Well, that's not gonna work here. Let's say 2. And we would expect that to equal 3. Okay. Seems like a decent way to model this tree. So let's go ahead and model it. Struct file tree node, or sorry, enum. No. Maybe we can do it with enum. So a name and its children. Maybe the way to do it is yeah, let's see if we can do it with a node. Enum file tree node. And then it can either be a leaf, in which case it has a name and a size, or it can be a branch, in which case it has a name and a vector of file tree node. You know what the problem with this is going to be, though? This is not very sized, right? Oh, looks like it is. I think I'm gonna get yelled at for that not being a size, but we'll find out. File tree node, and what to say here? Pub function leaf of name, the size should return self leaf name size. I don't really know why I need functions for these, but children self size should take a self and return a u size, and it should just be self Dutch. I guess I have to match first. Match self. If I'm a leaf, then maybe I should say length, not size. I think I probably should. If I'm a leaf, then I return 1. If I am a branch, then I return 1 plus I'm a leaf def of it doesn't matter. I'm a branch of it doesn't matter, and children. So children dot iter dot count. And let's go ahead and call this length. So now pub function. What else we got here? Depth. And that will be self leaf. Then your depth should be 1. And otherwise, we will say 1 plus children dot iter this is wrong. This should be a sum dot map child dot length dot sum. And then for this one, we need the child's depth, and we need to max it. Okay. And option usize. It need not have a max. That's fair. Let's panic if it doesn't, though. All branches should have a max. Should have children. And when we create the branch, we'll make sure that that's true. Assert that children dot length is greater than 0. Okay. That's a reason to have those as functions. Cool. Oh, I called them file and directory. Those are better names. File. Directory. And then these become file and directory. Okay. Alright, what else we got? We got sum sizes and sum sizes if. We need a name for this. Free.toString. And this needs to be length. Okay, sum sizes and sum sizes if. This will be name and size, so this will be size, and self-directory, name, and children. We will say dot map sum sizes dot sum. And I guess this needs to be dereferenced. Okay. And I guess actually we can say sum sizes if, and then we can say that this is a function of usize to bool. And we'll say if function of size then size else 0. This can be sum sizes if f, and then sum sizes is just self dot sum sizes if where f takes a number and returns true, so that we always sum all the sizes. Okay. And then gets, oh right, it's a function of the node. Do I care about that? Yeah, I think I kind of care about that actually. So this can be a function from self to bool. And this can be let's say I actually don't care about that for now. So let's just make this a function of size. Okay. And now this should run. Three versus 6 is what we get. 0, 1, 2. Oh yeah, because I would need this to be 4. What if I do 1 through 4 here? Nice. Okay. So that should let us construct the tree. So then the other thing we're going to need to do is be able to construct the tree from the input. I think I'm going to wrap up here though. We will start with that next time. The idea will basically be we'll have a way to consume each line and walk the tree, creating additional nodes. One thing that's going to be interesting is the way this kind of works now. You have to know, I guess I didn't need this. You have to know in advance what the children are, but you don't really actually want that. You want to be able to walk the tree and create the children at will. So we'll have to think about how that works, but I'm gonna do that next time. For now, I will just solve problem 5, 6, start on, 5, 6, start on 7, and we'll go from there. All right, hope everybody has a good rest of your day, and I will see you tomorrow at 1 p.m. EST. Cheers.